ahead and actually take a look at the AP practice problems from the practice exam that we took a couple days ago, and I want to make sure that you feel totally ready to do this. So let's kind of review and make sure that we have things right. So I'm going to be doing the multiple choice relatively quickly and kind of explaining it the way I do it as a person who has experience in AP physics, and this is kind of where the AP wants you with things too. So we want to know how far the object travels, and we have a velocity function, so you're going to want to integrate, so v dt. And that's going to give us, when we integrate it, I'm just going to do the integration in my head. This will be t squared plus t cubed. These factors absorb the division thing that you do when you integrate a power. And so when we put in the time, 10 seconds, we're going to end up getting 100 plus 1,000. And that gives us 1,100 meters. So that's choice D. Continuing problem number 2. We want to know what the instantaneous force is. So we know that this is V. 2t, so this is v, 2t plus 3t squared. Let's get the acceleration. That's going to be the derivative, so that's going to be 2 plus 6t, and so that is going to be 2 plus 6 times 2 is 12, which is 14, and so the net force is going to be m times a, that's going to be 10, the mass, times acceleration, which is 14, and that gives us 140 newtons. Awesome. Now we could do this the hard way, which would involve f dx, but since this is a function of time, we'd end up doing this weird thing of f dot dx dt times dt and integrating this crazy function to get the work. You could do that. I just don't want to. Instead, let's do work as the change in kinetic energy. Then what I can do is say 1/2 mv final squared minus 1/2 mv initial squared. And it actually turns out that the v at 0 is just going to be plain old 0 when we put in the number. So work is going to end up being 1/2 times m, which is 10. And then v squared, v final squared, is going to end up being 2 times 1 plus 3 times 1 squared. All of that quantity squared, that's 1/2 mv squared, and that's going to be 5 times, let's see, 2 plus 3 is 5 squared, 25. That ends up giving me 125 joules of work. Awesome. Now, for number 4, we've got a circular path. So we start here at the origin, halfway around, y is 3/4 of the way around, and z is back here. So let's rank the displacement from least to greatest. Z is the least, followed by y, followed by x. Choice E. And then for number 5, we have a particle with acceleration in 2 different directions, and we want to know what the x-coordinate of the particle is when its y-coordinate is 12. So let's set it up. In the y direction, 12 is 1/2 ay t squared. 12 is 1/2, the acceleration in the y direction is 1. That's t squared. And so t squared is 24 seconds. Let's not isolate that. Instead, let's get now what the x-coordinates. That's going to be 1/2 ax times t squared. And that's 1/2. Ax is 2, given here, times t squared, which is 24. That cancels, and so we get an x-coordinate of 24. An object is moving in a straight line at an increasing, if the speed of an object is moving in a straight line, if the speed of an object, let me try this like for the 900th time. We got an object, it's going in a straight line, but its speed as a function of time is increasing at a constant rate. That indicates, by the way, that the acceleration is constant. We have a constant acceleration. And that means F net is m times a, where this is a constant. And so that means that we have a constant non-zero acceleration. So that is the first page of the multiple choice on your practice exam.